This is question number 1 in the non-calculator section. We're asked to factorise 6ab minus 7bc. The first thing we need to remember is what the word factorise means. It means putting the brackets back in. Now, so far we have learned of 3 different ways to factorise an expression. The first of those, and the one we should always check for first, is a highest common factor. We also have a difference of 2 squares and factorising a trinomial. So looking for a common factor, the highest common factor, we should see that there is no number that goes into 6 and 7, and the only letter that appears in both our terms is the letter B. So that will be our common factor, which sits outside the bracket. We'll put our minus sign in the middle. So b times something in here has to give us 6ab, so that would be b times 6a. And then b times something in here needs to give us 7bc, so that would be b times 7c. There is no further factorising possible, so that is the final answer. This is question number 2 in the non-calculator section. We're asked to find the equation of the straight line AB. So that's the straight line shown here on the diagram, which passes through the 2 points A and B. We should be aware of 2 different equations that we can use in order to work out a straight line. When we have a diagram like this one here, where it's quite obvious where the line passes through the y-axis, then the best one to use is y equals mx plus c. So that's the general form of the equation of a straight line. The 2 different things that we have here that we need to find out are m, the gradient of the line, which is how steep it is, and c, which was mentioned a moment ago, which is the y-intercept. So that's quite clearly visible here on the graph. The line passes through the y-axis at the point 0, 4, which gives us a c value of 4. So what we need to do now is we need to work out the gradient of the line. So first of all, we can see because it slopes downwards from left to right, it means the gradient has to be negative. Now, since we are given the 2 points, 0, 4 and 3, 0, we could substitute those into the gradient formula, which is m for gradient equals y2 minus y1 over x2 minus x1, which would work fine. In this case, however, and since we have a diagram which we can easily refer to, a simpler formula to use would be m equals v over h. So m is for gradient and v and h are the vertical height and horizontal distance on a triangle which is created using our 2 points, or in fact any 2 points on the line. So studying the triangle carefully, we can see that v, the vertical height, is 4 and h, the horizontal distance, is 3. So that then gives us 2 numbers that we can substitute into our formula. So m for gradient equals, and then it's 4 over 3. And we need to remember at this point that since it's sloping downwards from left to right, that the gradient is negative. The next thing that we want to do is substitute this value for m along with the y-intercept into our equation. So m is negative 4/3. We mentioned earlier that the y-intercept is 4, so we can take those and substitute them into our equation. That gives us y equals negative 4/3 x plus 4. That is the equation of the straight line and the end of our question. This is question number 3 in the non-calculator section. The diagram below shows a sector of a circle centre C. The radius of the circle is 5 centimetres, so that's from here to here, or in fact from here to here. And angle ACB is 72 degrees. We are then asked to calculate the length of arc AB, which is the length of this curved part of the circumference going from A to B. And we're told to take pi equal to 3.14. Now normally we would associate these arc length questions with the calculator paper. So the fact that it's in the non-calculator paper means that hopefully the numbers that we're going to deal with will be straightforward. Now we have a formula to use for arc length, and that is arc length equals, and it's pi times the diameter, since we're talking about part of the circumference, multiplied by the angle over a full circle, which is 360 degrees. So our arc length is pi, which we'll use 3.14 here, multiplied by the diameter. So we're told up here that the radius of the circle is 5 centimetres, which means the diameter will be double that at 10, multiplied by the angle at the centre, which is 72 degrees, divided by 360 degrees. Now, at first glance, this part looks as if it might be quite difficult to do, given the fact that we don't have our calculator. But 72 over 360 simplifies. In fact, 72 goes into both 72 and 360. So 72 into 72 goes once, and 72 into 360 goes 5 times. Now that's a stroke of luck, because we're going to multiply 10 now by 1/5, which is a fairly easy calculation to complete. So we have 3.14 multiplied by the 10 and then multiplied by 1/5. So we're going to do the 10 times a fifth part, or 1/5 of 10, which is just in fact 2. So the next line will be 3.14 multiplied by 2. So that's a calculation that we can do even in our heads. So 2 times 3 is 6, and 2 times the 1/4 or 14 part is 2/8. That then gives us our answer for the arc length of AB, which is just simply 6.28 centimetres. That's the end of the question and our final answer. This is question number 4 in the non-calculator section. We're asked to solve algebraically the system of equations. So we should recognise this straight away as a simultaneous equations question. We'll make the equations a little bit bigger and put them over here. So in order to proceed with these ones, what we do first is we usually label them 1 and 2. So we'll do that straight away. And the next thing that we attempt to do is eliminate either the x's or the y's. So it doesn't really matter which one you go for first, just which one is easier or more convenient. So in order to eliminate them, we want to give either the x's or the y's the same value, and we want to make one of them positive and the other one negative, so that we always just add after that. Now, since the y's already are negative and positive, we'll start with those. So what we want to do here is multiply equation 1 by 5. So that means we multiply not just the y's by 5, but all the terms in the first equation. So first of all, we have our 2x, and we're going to multiply that by 5. So 2x times 5 is 10x. And then we have our negative y. So multiplying that by 5 is negative 5y. And then equals, and then we have our 10. So if we multiply that by 5, we then get 50. The second equation remains unchanged. So that's 4x plus 5y equals 6. So now we have the same value on our y terms, one of them positive and the other one negative. So to eliminate them, what we do now is we add the two equations together. What happens then is that the y parts disappear. So 10x add 4x is 14x. The y parts disappear when added together, and 50 add 6 is 56. So that gives us 14x equals 56. So then we take the 14 to the other side, which means it then divides the 56, and 14 goes into 56 exactly 4 times, which means that x equals 4. So our next step is to try and find y. So we then want to substitute x equals 4 into the first equation. So we'll write that down as a little heading here. So that first equation was 2x minus y equals 10. We now know x is equal to 4, so that's 2 times 4, take away y equals 10, which then gives us 8, take away y equals 10. Moving the 8 to the other side, we'll change it to negative 8. That leaves negative y on the left hand side. We already have 10 on the right hand side, and the 8 comes over to be negative 8. So that then gives us negative y equals 10 take away 8, so negative y equals 2. If negative y equals 2, then that means y equals negative 2. So that completes our solutions, which we should probably write down again at the end. So x was equal to 4 and y was equal to negative 2. Now what we can do, if we want to check if these are right, we can take those and we can substitute them into equation number 2. If we do that and the equation works out, then we know that these two are the correct answers. This is often written as a point of intersection. It refers to the point where the two equations or the two lines cross over. So the point of intersection in this case would be the point 4, negative 2. That's our final answer and the end of the question. This is question number 5 in the non-calculator paper. So we're given this diagram, which includes a circle, some triangles inside, and then this line on the outside. We're told that the tangent SV, so that's the line that we just mentioned, it's a tangent. It touches the circle, which has centre O at the point T, so that's where the tangent meets the circle. Angle PTQ, which is this one here, PTQ, is 37 degrees, and angle VTR is 68, so VTR, that's this one here, it's 68 degrees. We're then asked to calculate the size of angle PQR, so PQR means this angle here. So we'll draw this one in since this is the one that we're looking to find. Now, a lot of information has been given there, but there is also a lot of key information missed out, things that we should already know. Most importantly is the presence of several right angles. The first of these is the touching point of the radius and the tangent. So our radius is this line here, our tangent is this line here, which then means that this angle between the two is a right angle. So mark that one in just now, that's a right angle. Also, we need to be aware of the right angles created inside a semicircle when we have a triangle. That then means that this angle here is going to be a right angle, and also this one over here is a right angle. This then gives us more information to work with to help us find the angle we mentioned at the start, this one here. So what we're going to do at this point is we're going to think about that as two separate angles. This one that I have marked in yellow and this one here that I've marked in green. Once we know the yellow angle and the green angle, we will then add them together to find angle PQR. So we'll look at the yellow one first of all. It should be the easiest one to figure out. It is one of 3 angles inside this triangle here. Now we should remember that the 3 angles in a triangle add to 180. So since this one is 90 and this one is 37, then the yellow one will need to make it add to 180. 90 and 37 adds together to give us 127. If we then subtract that from 180, we get 53 degrees. So our yellow angle here is 53 degrees. So what we want to find next is the green one. Again, it's part of this triangle here at this side. We want to find the green angle. We know that this angle is 90, but the problem is we don't know the size of this one here. So I'll mark it in. That's the one we're trying to find. What we do know, however, is that from here round to here is 68 degrees. And since also we remember that the angle all the way around is a right angle, so this is 90 degrees, then that means the one that we're looking for, this one here, will simply be 90 take away 68. So that gives us this angle as 22 degrees. So since the right angle in the corner is 90, this one here is 22 degrees, then the green one will make it add up to 180 again. 90 add 22 is 112, and 180 take away 112 is 68 degrees. Adding these two together gives us the angle that we are looking for. So 53 add 68 is 121 degrees. That's the size of angle PQR and the end of the question. Question number 6 in the non-calculator section, we're asked to simplify this fraction. Now we're not told to do this, but we should know that we need to first of all factorise the denominator. The numerator is already factorised. So we'll attempt to do that over here. So first of all we'll write down the denominator expression, which is a trinomial, x squared minus x minus 20. We should remember that this type of expression factorises into double brackets. Now I tend to do the working for these over at the side, where I put one of the brackets above the other. So starting with the x squared, we will get that by putting an x at the front of both brackets. Moving then to the number at the end, which is 20. We need two numbers that will multiply to give us 20, but somehow also add or subtract together, combining to give us negative 1x in the middle. So the two numbers that spring to mind are 5 and 4. 5 times 4 gives us 20. So we'll put our cross working in. X times 4 is 4x, and then x times 5 is 5x. Those two things have to combine by adding or subtracting to give us the term in the middle, which is negative 1x, and the sign is important here. So how are we going to do that? We want a sign in front of the 4 and in front of the 5, so we should realise that those would be plus 4 take away 5, giving us negative 1x. So our x and 4 multiplied to give us a positive 4x, which means the 4 has to be a positive, and then the x and the 5 multiplied to give us negative 5x, which then tells us the 5 has to be negative. Those are our two brackets which we need to write in beside each other, so that's x take away 5 and x plus 4. So this is just a working section for our original question, which was to simplify this fraction. So we'll write down the next line of working for our fraction. On the numerator we had x plus 4 squared. So if we want, we can write that out as x plus 4 multiplied by itself. And the factorised denominator, which we worked out a moment ago, is x take away 5 and x plus 4. So now we can see that we have a bracket on the top, which can be cancelled with a bracket on the bottom. That then leaves us with x plus 4 on the top, no real need for the brackets now, and x minus 5 on the bottom. That's our fraction fully simplified, so that's the end of the question. This is question number 7 in the non-calculator section. We're asked to state the period of y equals sine 2x. This is a trig function. We should be familiar with trig functions like y equals sine x and y equals cos x. They are repeating functions which are said to be cyclical. So the period is the length to complete one cycle. Now the graph of y equals sine x, first of all, we'll put that down here. Now this sketch shows one complete cycle of the graph, and we can see that that takes 360 degrees. So that means the period of y equals sine x is 360 degrees. We, however, are looking for the period of y equals sine 2x. Now that function differs from the function on screen because of the presence of this number 2. So what that actually means is it means that we have 2 cycles present in 360 degrees. So that means this time that a single cycle is completed after just 180 degrees. So that then means that the period of the graph we are looking for is actually 180 degrees. So how do we actually do that in practice? Well, the period of the original graph was 360. We just simply divide it by the number in front of the x. 360 divided by 2 is the required period of 180 degrees. That x value would be in fact 4, so we'll substitute that in. 20 take away 4, take away 4 all squared. So our value 4 in here makes the bracket disappear. When the bracket part disappears, we're left with 20 take away 0, which means y equals 20. So what that is the y value of our turning point that goes with the x value already mentioned. So our turning point up here at top will have coordinates 4, 20. That's what the first part asked for, so that's the first part answered. Part B then asks us to state the equation of the axis of symmetry. So we can see that our parabola is symmetrical. So the axis of symmetry would be a straight line which comes down through the middle, passing through the turning point. It clearly passes through this point here on the x-axis, and that is directly below our turning point up here. So that means that this x value has the same value as the x value on our turning point 4. So this point here on the x-axis is x equals 4. That also represents the equation of our axis of symmetry and the answer to part B. This is question number 9 in the non-calculator section. We're asked to sketch the graph of y equals sine of x minus 90 degrees, where x lies between 0 and 360 degrees. Now the first thing we want to do here is first of all make a sketch of the graph of y equals sine x. That will give us a starting point. Now the graph that we are looking to sketch, y equals sine of x minus 90 degrees, will be this graph but moved to the right by 90 degrees. We only want the parts of the graph that lie between 0 and 360 degrees. So that means that this part of the graph is going to disappear when it moves off to the right. But what it also means is that part of the graph that isn't sketched at the moment in here will then become part of our sketch. So we'll start by putting that part of the graph in. So what we'll do now is we'll take some of our key points for sketching and we'll move them all to the right by 90 degrees. So our original one at 0, this one here at 90, this one at 180, this one at 270, and then this one at 360, which will disappear off the graph. but also now this one here at negative 90. Now each of those points is going to move 90 degrees to the right. So we'll show their new positions with yellow dots. So first of all, this one here will move from here to here. And then this one here will move from here to here. This one up here will move from here to here. This one at 180 will move from here to here. And the one that was at 270 will move from here to 360. From here to here. So that gives us our new points so that we can draw our sketch. And I'll attempt to do that now with my yellow pen. So starting here, our curve will pass through each of the yellow points until it reaches 360 degrees at this position. So that's our sine graph, sine x shifted 90 degrees to the right. That then gives us the graph of y equals sine of x minus 90. We've only included the parts of the graph which lie between 0 and 360 degrees. That's our finished sketch and the end of the question.